Hello, college algebra students. This is the last video for section 2.3, and it is on local max and min values of a function. And a lot of this stuff was already discussed in the previous video when we did the increasing and decreasing sections of a graph, because it kind of is used for that. But we're going to talk more specifically about the local max and mins. You can see that from our textbook we have the formal definition of each, and I did discuss kind of similarly how to look at those in the previous section here. But anyway, when you're looking at a graph and you have a portion that is that where the graph is larger than the values that are kind of immediately surrounding it, then you would have a local maximum. And if you have a portion where the graph is smaller than kind of the immediate values around it, then that would be a local minimum. So this is not, you may have heard of, or we will talk about this at a different point where we talk about absolute maximum and minimum. This is not the highest point or the lowest point of a graph. It's just kind of a sort of a little hilltop or a valley, so to speak, in a location or a smaller location of a graph. So it's not like the end of the graph in terms of its maximum across all the intervals. It's just kind of a smaller region. So in the picture here, you can see that there are two different spots where local maximums occur, and two different spots where local minimums occur. So we're just gonna review on the calculator primarily how to access those. But you can refer to this definition if you want kind of a more of a formal analysis of it. Let's take a look at example 8. So in our calculator, let's go ahead and type in the function. So this will be x cubed minus 8x plus 1. And then let's go ahead and just find the same window together, just the standard window. So the standard window would be x from -10 to 10, and then y from -10 to 10. And let's take a look and see what that one looks like. So this one's pretty good. If you wanted to, you could maybe make the y values a little bit larger if you want to see the maximum a little more clearly. So if you wanted to change your y max to maybe 15, that might be a little easier to see, but that's totally up to you, obviously. So it looks like there's one local max and then one local minimum. And I'm just going to sketch this really quickly so that we can label our points. All right. So let's find these values. So as a reminder, your calculate menu, so if you press second and then the trace button, which is calculate, has two different options that we're going to be using. Number 3 is the minimum, number 4 is the maximum. So I'm going to find the maximum first. So I'm going to select option number 4. And then it wants us to give a left boundary. So we had discussed, just scrolling over so that you are left of the maximum, and then hitting enter, and that will allow the calculator to understand that that's the left boundary of where the maximum occurs, and then you go to the right of the maximum and hit enter, and that gives you a right boundary. So on your screen, you'll see those two little boundary lines show up, and then it wants you to guess. So you go close to that maximum and hit enter, and that particular maximum to 3 decimal places would be, let's see, -1.633, and the y value is 9.709. I'm just double checking that I wrote that all down right. Okay, so there's our relative maximum, and then we will find the relative minimum. So second and calculate, and then this is option 3. And then we'll do the same thing. We'll have a left boundary, which is maybe about there, and then a right boundary, and then a guess. So remember, the boundaries are they don't need to be too specific, but they just need to help the calculator kind of zero in on where that minimum will be. So this one's going to be 1.633 and negative 7.709. Okay, so again, this problem is asking us to find the local max and min values of the function and round to 3 decimal places. And so if we wanted to be a little more specific, the local maximum is negative 1.633 and 9.709, and the local minimum is the opposite x value, 1.633 and negative 7.709. All right, let's move on to the very last example. So this is just an application of this maximum minimum idea. So this is a traffic model question. So a highway engineer develops a formula to estimate the number of cars that can safely travel a particular highway at a given speed. She assumes each car is 17 feet long, travels at a speed of x miles per hour, and follows the car in front of it at a safe following distance for that speed. She finds that the number n, capital N, of cars that can pass a given point per minute is modeled by the function n of x. It's kind of a complex looking function, but the n, the capital N, is the number of cars, and then x is the speed. All right, so we're going to try to graph this function. So let's go to the calculator again. I need to get my calculator to work. Hold on here. I'm just going to refresh it. Oops. Okay, so in our calculator, there is an option to add a fraction. So for a problem like this might help us a little bit. Let's see, it's alpha, and then f1, so alpha y equals, and there's a option 1, it's n slash d, so that ends up putting in like a fractional form, which kind of helps to enter this one in without causing any errors because there's a lot of parts to it. And then you just try to enter it in so that it looks really similar, and you can do the alpha f4 again if you want to do the x divided by 20. Oops, I just messed that up though. And then all of that is being squared. So again, this notation can kind of help because then it allows you to type in exactly what you see in the problem. Anyway, so there's our function, and then we're going to do the viewing window, and just so that you know, this is going to be your x from 0 to 100, and then this is going to be your y. So when it says, 0 to 100 by 0 to 60, that means x by y. Okay, so in our window, we would go 0 for the minimum and then 100 for the maximum. You don't need to change your x scale unless you want to. And then it would be 0 to 60 for y. Same thing with the y scale. So here's our graph. Okay, so remember the vertical axis for the graph is the capital N, which is the number of cars, and then the horizontal is x, the speed. So I'm just going to do just a quick sketch of this. Okay, so we want to know what intervals is n increasing and on which is it decreasing. So we discussed this in the last section here, but n is going to be increasing here and then decreasing here. Okay, so we're going to need to figure out that maximum value in order to determine that. Now part B is asking us for the maximum value of n, so we're going to kind of do both things at once here. All right, so I'm going to go to my calculator and I'm going to do second and calculate and choose option 4, which is the maximum. And then we'll just scroll over so that we are left of the maximum and hit enter. Oops, sorry. And then we will go to the right and hit enter. And then I didn't really mean to go that far right. And then we'll go up to the top and get close for a guess and hit enter. Okay, so for the the local maximum, we have x is 20. It is 0.00007, so we're just going to round that to 20 because that would be accurate to 3 decimal places. And then my calculator, for whatever reason, says 880 divided by 17. So 880 divided by 17 is the decimal 51.765 if we use 3 decimal places. You could do the fraction, I suppose, but either way, that value is the number of cars. So neither the decimal or the fraction make a whole lot of sense. So we'll probably round that one. But anyway, when is n increasing? Well, n is going to increase over the interval from 0 to 20, and then n will decrease from 20 to, we're just kind of assuming that it's going to keep on going there, but actually let's go ahead and stop it at the viewing window, which would be 100. Okay. All right. In terms of the max value of n, so the max value of n is 51.765. That again is the number of cars. So when it says what is the maximum carrying capacity of the road, we would go ahead and just round that to 52 cars, approximately 52 cars, which is the carrying capacity. Okay, and the speed. So at a speed of 20 miles per hour, which is our x value there. Okay, that does it for section 2.3. Thank you.